Welcome everyone. We are going to study the next part of our chapter. This part of our chapter basically deals with the concepts of what is happening inside the source. What is happening inside the cell means what kind of voltages we know, what are the actual kinds of voltages are present there, and about their characteristics and relations. Mostly in physics, whenever we studied Ohm's law, we started talking about the potential difference, just before or after. Now when we are talking about the potential difference, what that potential difference is usually in an electric circuit, and is it the only potential difference or any other potential is present there? Let's look inside the matter. If you go further in detail, you will find out that the cells are actually of two kinds, primary cells and secondary cells. In a primary cells, two electrodes are given of two different metals, and one solution is given which performs or which helps in electrolysis. What happens in electrolysis? And electrolysis, just like in here we have used copper plate and zinc plate and sulfuric acid as electrolysis liquid. This dilute sulfuric acid must mention. Now in one plate all the electrons or all the negative charges move, and in another plate the positive charges move. Clear? In case of this, in the copper plate all the positive charges are coming. Clear? And in the zinc plate all the negative charges are going. Clear? Due to electrolysis. This part is called anode. I hope all of you remember. And this part is known as cathode. Now due to this electrolysis process, what is happening? Now in one portal we are getting positivity, and in another side we are getting negativity. So what will happen? Now this portion will have some positive charges and this portion will have some negative charges. Clear? Now due to this positive and negative charges, a kind of force is created due to this potential difference. This potential difference creates a kind of force which will push the electrons from the negative side to positive side, or it will, in a normal way, it will push the charges from positive to negative, and that force is called electromotive force. That force is known as electromotive force, or in short EMF of a cell. The electromotive force is usually expressed as the symbol E in volt, because it's a sort of potential difference. Clear? So this is the basic idea of electromotive force. Electromotive force is actually the original potential difference. You can see in this case we don't need a circuit. Even if the circuit is kept open, even in open circuit, we can calculate EMF. But do we calculate this potential difference every time or any other time? We will see that later. If I try to define the EMF of a cell, the EMF of a cell is usually defined as that it is an energy spent per unit charge. It's quite like potential difference. It is the energy spent per unit charge if a positive test charge is moved around the circuit and as well as inside the electrolyte of the cell. So it is represented by epsilon equals to work done per unit charge. That's quite a long definition to remember. Basically what? That if I just take a charge from here and it is moved through all the electrolytes, and if there is any circuit present, it completely moves from it and returns to the here, then comes back to this electrolyte to here, then the total work done to move this charge throughout any present circuit and plus through the electrolyte is called EMF. Means a charge will not only move to any present circuit, but it will also move through this electrolyte. Okay, through this electrolyte it has also to travel. So it is not only the circuit but also through the cell. But is this one we actually measure? The answer is no. What do we measure is called terminal voltage. Basically, we make a circuit like this. You can see we have make the circuit, the same battery system. There we take two terminals, terminal A and terminal B. From here the whole circuit is made, current is flowing, this is the resistance, okay, and this is the V we measure. Means we actually every day in every numericals, see the diagram carefully, we actually measure the voltage between two terminals of the battery. Just like if I give you normal to secondary cells, the dry cells you use, if you connect them, these two batteries here, just like you join them by a wire, you just measure the potential difference between these two terminals. You are not interested what is happening inside. Similarly, in this case of primary cells, if we measure between these 2 points, these two terminals, then that terminal potential difference, which is actually known as terminal voltage, is measured. But in addition to this circuit, if you measure the work done for the charges to move from here, to move throughout this electrolyte, so if we just add this portion of work done, then actually you are measuring the electromotive force, So what is the relation? Before going there, this terminal voltage is represented by V, and if current flow is I and R is the resistance, V equals to IR, that's the Ohm's law. Remember, now the relation is very simple. EMF epsilon is the work done for the whole thing, for the circuit plus battery. Clear? Whereas terminal voltage is the work done for only circuit, work done to move the charge circuit. Clear? So it is the work done, that is a terminal voltage for only circuit portion, and electromotive force is for both circuit plus the batteries inside case. Clear? So if I just take an easy relation, that let's represent EMF let's represent EMF as E. Sorry, this used in your chapter is the W by Q. Then this W is the work done for both movement of charge inside battery plus circuit. Clear? This movement is for both battery and circuit. Clear? Now if I consider for moving inside battery, W dash work is done. Clear? For moving inside battery, W dash work is done, and for moving in circuit, small w work is done. Then you can see what is EMF. EMF is equal to capital W by Q. What is capital W? Now work done for battery plus work done for circuit. Work done for battery is W dash and work done for W is small w. So I can write this W is actually sum of W dash plus small w by Q. Clear? So this is how we get W dash by Q plus W by Q. Now tell me, what are these two things? W by Q is the work done for moving in the circuit. What do we call the work done for moving in the circuit? Terminal voltage. That is capital V is small w by Q. This is the work done for moving in the circuit. So for this small w by Q, this will be called, this one is V, this one is called V. And what will you call this? What will you call this? This one is one more quantity. It is represented by small v. This small v quantity is called, voltage drop in cell. Clear? This small v is called voltage drop in a cell. So our final formula is, a small v is voltage drop in a cell, capital T V is terminal voltage, and epsilon is electromotive force. Then E equals to capital V plus small v. This is the form of our final formula. It is quite easy to understand. So this is we have to understand today. Thank you everyone for this part. If you got any doubt, this portion is little bit tricky, please watch the video again and again, and still if you are getting doubts, contact me in comment section or you can also inbox me. Thank you.